Every 10K, every 8K, and every initial public offering filing from every public company in America flows into a single database. This centralized system processes corporate disclosures and dictates the daily pace of global financial markets. In the 1970s, the SEC, the Securities and Exchange Commission, the federal agency tasked with regulating financial markets, was drowning in paper. Filings arrived by mail, by physical courier, and sometimes literally in suitcases. Because these documents had to be physically transported, unboxed, and manually filed, financial analysts waited days or even weeks to review a company's financial health. The data moved only as fast as a delivery truck. This massive physical lag created severe information asymmetry. Those who could physically access the paper documents in Washington gained distinct trading advantages, while average investors were left completely blind to the true state of the market. To solve this, the SEC launched a pilot program in 1984 called EDGAR. EDGAR stands for the Electronic Data Gathering, Analysis, and Retrieval System. The objective was to digitize corporate disclosures nationwide, an audacious technical goal to attempt before the widespread existence of the modern Internet. Early EDGAR did not use a relational database. It relied on a Unix operating system, a multi-user system heavily utilized in early server computing. The filings were stored as flat files in hierarchical directories. To organize the information, the system generated daily flat indexed files using COBOL, a standard programming language for early data processing. This diagram shows how the system structures its tracking. To find anything, you need an accession number, the primary key identity for a filing. It encodes 3 distinct pieces of data: the year, the sequence, and the submission batch. To connect those filings to a specific company, the system uses the CIK. Unlike a stock ticker symbol, the CIK is permanent. It acts as the identity layer, linking multiple accession numbers to one specific corporate entity over time. When the system officially went live in 1993, filings were transmitted directly to SEC servers over standard dial-up phone lines. The documents were formatted using SGML, or Standard Generalized Markup Language, which uses structural tags to define sections, tables, and signatures. By forcing companies to submit their financial data with these structural tags, this early Unix architecture turned corporate disclosures into queryable, machine-readable assets. By the early 2000s, the speed of financial trading accelerated sharply. The EDGAR system reached a breaking point where regenerating daily flat index files could no longer keep up with the sheer volume and velocity of incoming corporate disclosures. The SEC migrated EDGAR's indexing to an Oracle database. This relational system structures data into interconnected tables, managing timestamps and CIK records. This created a hybrid architecture. Metadata lives inside the structured Oracle database, while raw documents remain in distributed file clusters. Separating the structured metadata from the heavy raw storage meant the database could be searched instantly. Financial analysts no longer had to wait for overnight batch updates. They could query and retrieve specific corporate records on demand. To improve how the raw documents were parsed, EDGAR transitioned from the old SGML formatting to XML, or Extensible Markup Language. XML provides a much stricter set of schema rules for encoding documents, which allowed the system to parse data faster and enforce rigorous structural validation. With XBRL, companies tag specific metrics like revenue and cash flow, extracting them into discrete, machine-readable code. Today, filings drop through a massive pipeline for immediate syntax validation and virus scanning. Instantly, the system extracts metadata, generates indexes, and pushes data to public dissemination servers. XBRL and this ingestion gauntlet replaced passive document reading with active, real-time data querying. Analysts and software could now scrape structured financial numbers instantly, laying the critical data groundwork for modern algorithmic trading. In 2016, attackers successfully breached EDGAR. They bypassed the main protocols by exploiting a vulnerability inside the system's test filing environment. The attackers accessed non-public earnings reports submitted by companies before their official release dates. By weaponizing that premature access, the group executed trades based on the stolen data, generating millions in an international insider trading scheme. Following the breach, the SEC aggressively hardened the system. They deployed advanced intrusion detection, increased network segmentation to isolate the test environments, and added enhanced validation layers to the ingestion pipeline. The speed and centralization that make EDGAR so efficient also make it incredibly vulnerable. It serves as one of the highest value targets on the planet for global market manipulation. This diagram illustrates the SEC's current EDGAR Next initiative, which pushes the architecture into the cloud using containerized ingestion services and API-driven submission workflows. An API, or Application Programming Interface, is a set of rules that lets different software programs communicate with each other automatically. Yet beneath these scalable cloud upgrades, the underlying Oracle relational database remains firmly in place as the permanent metadata anchor of the system. Over 30 years, EDGAR evolved from a brute force fix for a paper crisis into a real-time cloud-native pipeline. It processes every disclosure, timestamps every move, and creates the infrastructure of trust required to run the modern financial world.